Hi guys. Um, the last video I talked about the basics of what off-grid solar is and um, what are the essential components for getting a working system. Today I'll be showing you my setup and we will be looking at some of those components we discussed in the previous videos in action. And I also told you some of my components and some of the things we also did not talk about, like add-ons that you can add to your solar off-grid system to make it more efficient. Fortunately, my panels are on the roof, so I'm not going to show them. I can't go to the roof now, it's very hot. But beside the solar panels, these are the other component that we talked about in the videos. We have the charge controller. In this case, I have two solar charge controllers. We have the inverters. This is a 3 kilowatt inverter, and we have the battery, which is what stores my energy. I have two batteries. Like I said, I have two charge controllers. This is an MPPT solar charge controller, and if you remember in the previous videos, I said there are two types of solar charge controllers. You have the MPPT and you have the PWM. Now, the major difference is that the MPPT is a much more advanced solar charge controller. It's able to take use the total energy being generated from your solar panel and use that to charge your battery efficiently. The PWM has some limitation, especially if the voltage, if there's a huge difference between the voltage coming from your solar panel and your battery, you have some losses. It's not able to use, so sometimes you lose close to 30% of the energy being generated by your solar panels. So these are MPPT charge controllers. I have two. I have 4 solar arrays in the roof, so 4 of them are connected to this. I have 240 watt solar panels times 4 connected to this charge controller here. I have 220 watt solar panels times 4 connected to this charge controller here. If you recall, in the previous videos I said that the solar charge controller helps you to charge your battery efficiently so that you don't overcharge it. So in this case, the battery is saying float means that your battery is about 85% full. So bulk is when your battery is between 0 and 70%. So when the battery is at absorption, sorry, not float, absorption is when the battery is about over 85% full. When it says float, that means the battery is 100% full. The most charge controllers come with a display that allows you to see what the charge controller is doing. So right now you can see this is my PV voltage. This is the voltage coming from the solar panels. And let's look at the battery voltage. The battery voltage is 26.8. Now, this battery here are 12 volt batteries. So I connected two 12 volt batteries in series will give you 24 volts. So this is a 24 volt system. And because it's a 24 volt system, the battery bank, when it's charging, the voltage of the battery when it's charging is about 28 volts. In this case, 28.6. So while 60 volts is coming from my solar panels, the charge controller would step that down because 60 volts would destroy my battery. So it steps it down to a voltage that the battery the voltage that would efficiently charge the battery. Now, when the battery is full, it reduces the voltage and also reduces the amps. Right here I have a battery monitor. And this is not a core component. I didn't talk about this in my video because it's like an add-on, like an option. But it's a very important device. What it does is to help me to know what state my battery is. If you remember in the previous video, I talked about charging your battery. How do you know when your battery is full? Now, most of the batteries you see in the market, there are no indication. There is no way for you to know when they are full. Deep cycle batteries were actually meant for motor cars, but were adopted into off-grid solar. That's lead acid batteries, and deep cycle batteries were introduced um, to kind of fit into the special needs of off-grid solar. So they are not really smart devices. And so I installed a battery monitor. And what the battery monitor does is to monitor my battery to provide the kind of functionality you get on your laptop and you get on your phones, which is to know, oh, my battery is getting low. This is the state of my battery. So what it does is to give me the net uh, input or output from my battery. So right now I can see that 6 amps is going into the battery, and the battery is 97.3 percent full, just about minus 3.8, so it needs like 8 amps for the battery to be full, which means that what I took last night, so far I've been able to replace most of it less 8.3 amps. So this battery monitor gives me the true state of the battery. If you look at the second charge controller, you will note that it's saying float. Float means that the battery is full. So this charge controller is saying, okay, so I have this guy doing most of the work, and you're producing so much energy. If I add my own contribution to it, I might damage this battery, so it gives up and then says the battery is full. And that is because this guy is doing most of the charging. So um about 6.7 amps is going into the battery. Now this, at this stage, most of what I'm generating is going to waste. And you should note that the house is being powered from solar. I don't have any grid whatsoever. In fact, I don't even have a connection to the grid. There is no connection to the grid. There's no infrastructure. The infrastructure is not even there. So right now I'm generating enough energy. My panels are generating enough energy, or have the potential to generate enough energy to power my house and at the same time charge the battery. So I'm powering the house with what is coming, and I'm charging the batteries at the same time. Now, what is being generated from my solar panel is about 3.382 watts. I'm going to turn on the chest freezer. I turned it off briefly to, oh, so the battery is full. Now the thing, it just went to float because I noticed that the wattage dropped drastically, which means that the battery is full. And although it's a bit cloudy day to day, so I see it's varying, and you can see what is going into the battery has reduced drastically. And although this here says that the battery is still 97%, sometimes they go out of sync. And in most cases when this happens, what I do is just to reset the charge controller. But I'm going to turn on some appliances now because I needed to do some work on the system, and I turned off the freezer. So what I'm going to do is I'm going to turn on the freezer, and you will see that once the charge controller senses that the load in the house has increased, it's going to increase also dramatically. So I'll be right back. Okay, so I just turned on the freezer now, and you can see that the watts have jumped. I'm now generating about 285. Now this is a panel. When I really put it to its work, it's able to generate close to 700 and 800 watts. So I'm using about 20%. My use is so there's my battery is full, and I don't use. I mean, even though I'm powering so many things in my house, one of my panel is generating just about under 250 watts, and that is enough to keep the house in order. I also have some, remember the last time I talked about safety. And safety comes in, we're dealing with electricity here. Electricity can kill and it can cause fire, which would damage so many things. So safety is very important, which is why you need to use some form of safety fuse or circuit breakers. Now I have every component, every part of the system is terminated to a fuse. There's a fuse, for example, between the charge controller and the battery, and there's another fuse between this charge controller and the battery. There's a fuse between the inverter and the battery, and there is another fuse between the inverter and the house. So all this is to ensure that if there is a problem between in any of my devices, so if this charge controller malfunctions and maybe short circuiting is when positive and negative combines. Bad things happen when positive and negative combine. This would send it could cause a whole lot of energy to be released at once, and when that happens, the circuit breaker will trip, preventing this circuit from building up. So I have my breakers here, and I ensure that I use very thick cables, because when you're dealing with DC makes use of relative low voltage but very high currents. So you need very thick cables. These are like 10 mm wire. So if you have an installer doing this for you, ensure that your charge controllers has very thick cables. You can see that the cabling connecting to the batteries are also very thick. These are about 70 mm square cables which are connected to the batteries. Right here I have what is known as a bus bar. So if you look at our diagram, the charge controller, the two charge controllers, the inverter, everything connects to the battery. So I separated the positive of all these three devices. The positive wire coming from all these devices terminates to this bus bar, which is a very big slab of copper. Copper is one of the most conductive metals you have out there. So you have this bus bar, has the positive leads coming from the controller and the inverter, the two controller and the inverter. So there is just one cable in connecting to the battery. Now this allows the system to be very neat. It makes it very easy to troubleshoot, makes it easy for me to disconnect any component there. The same thing with the negative leads. You can see the three negative wires coming from the charge controllers and the inverter terminating to this shunt here. This battery monitor, this guy here uses the shunts. It is the shunts that reads the negative feeds coming from the inverter and the charge controller connects to this shunt, and this shunt reads what goes into the battery and what comes out of the battery, and that's what is used to know to regulate the battery, to see the different state of charge of the battery. I'm going to reset the controllers. So resetting them means I'm disconnecting the solar panels, and this is another importance of having circuit breakers. I can disconnect every component in the system. Let's say I want to carry out some work, I can disconnect it. So right now the solar panels are off. You can see they are blinking, which means that they are off, and this guy is already reading 0. So I turn them on, and you see that the panels will wake up and this figure will start rising. And importantly, you will see while okay, now let me turn this off again for you to see the battery monitor. So the battery monitor, now all the what is coming in to the battery is off, and the negative sign shows that I'm discharging the battery. It means I'm taking about 347 watts from my battery. And when I turn on the solar panels, you will see that this figure starts to reduce because more electricity is coming to the battery than is going. So you can see that the solar panel is generating about 700, just hit 700 now. Now remember that the battery is full for the most part, and what I'm doing is to top it off completely, to fill it up to the very end, because it seems the charge controllers gave up when the battery was at 97. Sometimes it happens. Could be a bug with the controller. Sometimes the charge controller and the battery monitor, they don't go in sync. So the battery monitor is telling me your battery is not full. It's just there are like 3% remaining for you to be absolutely full. And the charge controller say, yeah, this battery is full. So that's one of the importance of the battery monitor. It gives me the true state of the battery. So right now I'm generating about 700 watts. I expect this to drop within a couple of times, because out of which about 10 amps is what is going into the battery. So about 200 watts from 600 watts. The rest is being used by the house. Now when you look at the here, it's already saying float, so immediately the charge controller sense that this battery is full. I'm dealing with a full battery here, so both charge controller are saying absorption. So from absorption it will go to float. So I am sure that with this the battery would get filled up in no time. So in a nutshell, this is my setup, my off-grid setup. It's been serving me now for close to 2 years. I've had some upgrades to the system from where I started up from, and this is the latest iteration of my setup. The next couple of videos I'll do an in-depth review. This is a bit, now that I've introduced some concept like circuit breakers and cabling and charge controllers and batteries. The next video I'm going to do some review of some of the components I'm using, in case you want to get solar components, you're thinking of getting them. Now I need to add something. All this you're seeing here, I build them. I didn't manufacture the components. I bought the component and I fixed them, and I did the layout, and so it's a DIY system, it's a do-it-yourself system. I didn't use any of the installers, but I'm quite confident. I've run this through some professionals, and they gave me the thumbs up. So this is something that it's not impossible. You can do it. The knowledge is there, the knowledge is open, and this is why I'm doing this video, to kind of share some of that knowledge in case you want to do something similar. You want to have an off-grid setup and you're thinking of where do I start. So this is why I'm doing this video. We're going to talk about so many things. We're going to talk about efficiency. We're going to talk about what to watch for when you want to get an inverter and whatnot. So please, if this video has been useful to you, like, subscribe, and please, I love your feedback. I would like to get your feedback to tell me what you would like to know. One thing you should know, I do not have an electrical engineering degree or any form of certification. So please take what you hear from me with a pinch of salt. I think you should do your own research, and you don't have to just take it like the gospel. Yeah, so this system has been working for me. So this is what I'm doing. I'm not giving this is not like a professional advice or in anything. So this is my setup. If you have questions, ask. I'll try as much as possible to answer those questions, and thank you very much for watching.